I'm sorry. So, good morning and welcome back to the class on smart materials and structures. So, as we were discussing in the previous classes related to the case study on smart cities as well as on optic MEMS, right? So that case study was specifically for MEMS device, which was into the microfabrication. So apart from that, all the actual devices, what we make and use in the form of smart structures, you should know the state of art of how these smart structures can be developed by all the type of materials what we have studied related to different modules. We also dealt about the mathematical modeling, the derivation part, and how to relate its physical properties to specific applications. So you have like an thorough knowledge related to all the class of smart materials and how to develop a smart structure at the actual level and even at the micro scale we have studied. And also we focused totally on the device making of sensors and actuators. So with this concept of all the things what you have studied separately, so it is like a single stretch wherein you come across all the things what you have dealt. So I thought let me just provide a case study which brief out each and every module what you have studied, because we have gone through the case studies individually with respect to module wise. So this is like an overall which provides you a guideline in which you can proceed follow as well. So kindly go through it and keep yourself with the topic ready, right? So after this I'll be asking you people to speak on. So let me start with the right. So this will just explain the state of art and importance of smart materials and structures and what are its applications basically, right? So it was a research article which was published in the year 2018. Okay, so it was in collaborative work in with the Department of Mechanical and Electrical Engineering together, right? So it was being worked in Kuwait. The college name is Australian College of Kuwait. Okay, so with this aspect, what these guys want to let us know is to know that the class of materials or the world of materials is really an external and important classification which is very much essential to making any product, because it always helps to get the exciting results when we perform some experimentation. And while performing the experimentation, many challenges come across. It is not like a specific field, right? So in any extreme challenges which come in when you want to develop some devices from materials, so this helps to gain knowledge and to see which are the key parameters which plays a dominant role. So all these aspects of material class and its properties will help to make the world to move towards an extreme technology specialization, so wherein indirectly it helps for more evolution of the human civilization, right? So basically this class of smart materials have a huge demand in the field of aerospace, defense, automotive, and many other industrial branches what we have studied earlier. Why they are giving so much of importance related to smart materials is because it helps to change the physical properties with response to the external stimuli. It is not that it will retain the same properties what it had before being synthesized, before being developed into a device. No, any sudden change from the external stimuli, it can react and provide that respective physical property, which is required as an application part of you when you put this material into a device shape, right? So this is the main key feature why these materials are in a huge demand, right? So this is just a key abstract overview. So here the keywords are mentioned as actuators, sensors, piezo materials, shape memory alloys. Why? Because so they are using these actuator devices, sensors, which are made up of piezo material, shape memory alloys, what you have studied. So you can understand which material plays a vital role in which type of devices, because you have a specific module on devices, you have specific modules on different types of what we call the smart materials, right? And also on the smart structures, wherein we speak about the optical fibers also, right? So this is a good amount of information what you get in a single stretch, right? So this is the thing what you have to understand. I'll go directly to the this introduction part is just related to the literature survey. So what you are thoroughly aware of. So you know what you mean by smart materials. We have defined everything. The same thing has been written in the form of paragraphs. So I don't want to repeat the same thing in each and every module. So let me go to the rest part of it. So before, without going into the theory, if you can see the table here, that provides the overview of which are the class of materials which plays a vital role and which need to be selected and which not. Depending upon the response what you need, you can go for which type of sensor you need and which type of actuators you need, because you have sensors, a huge class of classifications what you have studied, and how to make this into a device also you have studied, what are its applications also you have gone through. Similarly for actuators also we have dealt the same way. So now in a small table the entire thing you can put into a glance, right? So suppose if you speak about the sensors here in the table, you can see like various material classes. So it could be an pyroelectric material, a piezoelectric, electrostrictor, magnetostrictor, electroactive polymer, electroluminescent, photoluminescent, electrochromatic. Okay, so these are the various class of materials which are available to get the sensors. It is not like only by piezoelectric material you will get the sensors. Yeah, only by using magnetostrictic material you will be getting the sensors. Yeah, only by using pyroelectrics you will be developing the sensors. No, depending upon the requirement, what is the stimuli to which you can get the change. So based on that, you can select which type of sensor you need for which type of application. So these are all different varieties and class of smart materials again. Okay. So if you use a pyroelectric material for a sensor development, it shows you the change with respect to the temperature, right? So if there is a sudden change in the temperature, right? So it provides the change in the physical properties as per the requirement for the application point of view. Suppose if you use piezoelectric, obviously it should provide mechanical strain, then only it can provide the required output. In the same way, for electrostrictors also, the mechanical strain, it will respond to the mechanical strain only. If it is magnetostrictors also, it will respond to the mechanical strain. So when you have three versions for the mechanical strain, you should see that what is your requirement. Okay, so based on that, you can select. And for all these three, you have to see that it's mandatory that the polarization has to be done, whether it is pyroelectric or piezoelectric. Polarization need to be done. Electrostatic polarization has to be done. If it is magnetostrictic, then it is always subjected to the amount of magnetic field it's been applied. Okay, so these are the things you have to keep in mind. And similarly, for the other class of materials, you have the stimuli to which it will change. For electroluminescent, it provides you the change with respect to the electrical field. For photoluminescent, it is depending upon the incident light. And similarly for the others, you can go. So we have focused majorly on piezoelectric and shape memory alloys and some part of magnetostrictor. Why? Because your module focused in depth related to the synthesis of piezoelectric material, shape memory alloys, its classification properties, synthesizing root applications, and mathematical modeling part. And hence you know much about these two materials. But apart from that, the ER fluid also we have studied to some extent, MR fluid also we have studied to some extent, and electroactive polymers also we have studied to some extent. Okay, so all these are again a different class of materials. So here the response and the stimuli to which it changes has been given over here. So based on the requirement, you have to select which has been needed. Okay, so after that, they have just given the information about some smart structures. So before going into that, I just want to give an information related to smart structures. So when you speak about the smart structure, it is not that it is constrained to a specific shape. The smart structures can be developed related to the different shapes. So several shape comes into picture. So when you are developing a smart structure, you should focus on the vibration control applications also. For that reason, you had a module where we spoke about the vibration absorbers and associated optical fiber concept also, because you should see that how the vibrations are controlled when you use or develop the smart structures basically for specific applications. And hence each and every module you have studied is very much important to make a smart structure, right? So you should focus on the micro positioning, the antenna, what is the shape control parameters you need, all there are many other practical things which comes into picture. So you will realize when you do this in actual. Okay, so if we speak about the vibration control application, it mainly includes related to the vehicles, right? So when it is movement with respect to the suspension system, the vibration can come into picture. So how to control that? Okay, so active vibration control in the application of aircraft, yeah, aerospace, aircraft vibration, how to reduce it. So all these things will be helpful if you analyze vibration control applications for smart structures, right? So based on that, the smart structures are classified into different sections that you are aware of. I don't want to repeat again. And directly I want to come into the general framework of smart structure categories, how it will be like. Okay, so this is to claim that it is smart, it is actively smart. Okay, when an smart structure can perform, then you can say that it is actively smart. If it is a passive smart structure, it can just sense, right, and provide the output in the form of data what is been sensing, so that the others will read the data and do the things accordingly. But you cannot claim that as active. If you are claiming that as active smart structure, it should be able to sense and perform the work without the intervention of human being. So that is to be claimed as actively smart. So this will come into picture when you have a controlling unit. It could be either due to IoT, yeah, COT, what we studied yesterday. So purposefully I did that case study yesterday so that this part will be clear enough for today. Okay, so that it will be controlled in required aspects. If it is a smart city, then COT comes into picture, cloud of things. If it is only focusing on a specific device, a specific structure, then only IoT is more than sufficient. For all these, you need a controlling unit, and as these two circles are bounded by a controlling unit. Okay. But to make this an actively smart structure, you should be having some device which has to sense what's happening in that structure, right? So you need a sensory system, sensory node you have to, and that sensory node will integrate with respect to n number of sensors which will be there. So you need more sensors depending upon how many devices you have within the structure. So it has to sense the data from each and individual devices, right, for that purpose. And all the data segregated by these sensors will be connected by the sensor node. And similarly, you should be having an adaptive part, so which has to adapt themselves to the data which is sensed, and that will be transmitted to the controlling unit, and they will provide the instruction, and that instructions has to be carried forward into an implementation of the work, right? So you need an adaptive part. So this is how a general framework for any smart structure category usually look into. And all these concepts related to the smart material got a high initiation during the time of World War II, right? So which focused a high demand for ferroelectric materials. Okay, so this was the first initiation which was done related to the ferroelectric material. So at that time, the generally available ferroelectric material was the crystals of the quartz. Okay, So now the regular properties of the quartz as a natural crystal is now enhanced by developing the artificial piezoelectric ceramic materials whose properties are really very excellent. So based on the evolution of these ferroelectric materials, so this ferroelectric will be having the nature of piezoelectric characteristics also. Okay, so you can even call those as ferroelectrics, not a problem. So based on the class of availability of the materials, many people did many research and showed like for which applications that could be used directly, so many things. So in the beginning, they produced the products called audio transducers. Okay, for direct connection with electrical circuits. They developed small piezoelectric igniters, right? So also they used piezoelectric filters basically for radios and TVs. Initially, we used to have big TVs, right? So in all those, they used to have these piezoelectric filters and the remote controls, the TV remote control what we use, right? It consists of ultrasonic transducers. So even these transducers could be made up of piezo element. Okay, so these are the applications wherein it was used long back since 1970 after the World War II. Okay, so this was a progress related to the smart materials in our previous history also. Right, so here they have just shown you some cantilever piezoelectric beam with double PZT patches. So I used to tell a unimorph, a biomorph always, and I used to tell that one layer or two layer. The same thing has been shown here. So when always we speak about an cantilever beam, you'll be having a beam. It could be made up of an hardened stainless steel, okay, depending upon what strength you need. So on that you can embed the different patches of the piezo layer, but you should be having a bonding layer in between, which is nothing but the adhesive layer. Okay, so this black color is the bonding layer, what you visualize.
Excuse me,
Hello,
ma'am. Yes, ma'am. It's in the first page only, ma'am.
you are
Like,
not able to see. Okay,
no,
you are
ma'am.
telling me now. Okay, this image, what I was explaining, did you see this?
No, ma'am. The slide is like first what you showed was abstract till there only.
Okay, you would have told me before, no?
I thought it's my phone network problem.
Okay, let me share again. Now, is my screen moving?
Yes, ma'am.
So first we dealt about the abstract part. So after this, I showed you the table which helped in understanding the different class of materials for sensors and actuators. What you have studied already, right from piezoelectric to that of ER/MR fluid, including our shape memory alloys, right? So which are the stimuli to which it responds, right? So for this, what has to be the initial requirement, like the polarization, yeah, magnetic field, yeah, emission of light. So all those things I just explained you in detail. Anyhow, I'll share this case study also with you. So then later I told you the importance of smart structure. So why it is being used? Like it could be used in different shapes and also to control the vibration aspects wherein usually it comes into. Okay, so usually vibration things usually comes in the aircrafts and other part where continuous vibration comes into picture. So in that cases also this vibration control applications could be used. For that purpose only we studied the vibration absorbers and optical fibers associated to the module. Three or four, three I guess. Yeah, third module. So then, due to this World War II, the initiation of these piezo materials came into picture. So, wherein the quartz was a natural element which was being used at that time, and later many invention related to the piezo material came. So, which were used in regular basis in many applications. Whereas in piezo ignition system, powerful sonars, also related to the transducers. So many applications wherein it was used during the time of World War II. So after World War II, still more patents came into picture. They identified still the use of these piezo materials, and they started using in day-to-day activities like piezoelectric igniters, ignition system, piezoelectric filters in our radios and TVs, and also in television remote controls. So all these aspects they started using the piezo materials for the smart structures. Okay, smart devices we can tell, not exactly the smart structures. Okay, so before that I also explained you the general framework of how the smart structure usually work in, right? So this also I explained you wherein we can claim the smart structure as an active or an passive. If the structure what you have developed will respond and work for the stimuli which has been sensed, so then only you claim it as an active smart structure. Okay, so to claim it is a smart structure, it should be active. So if it has to be active, it should sense what's happening in the room and the action has to be taken. So then only you can claim it as an actively smart. So this can be possible if you have a controlling unit, a controller, so that it will sense the data and it will that data will be transmitted to the controller, and the controller will provide the instructions, and as per that the active member, which is nothing but the actuator, should perform the work as per the instruction given by the controller. So when the instruction is given and the actuator performs the work, you should be having an adaptive environment in the room which will adapt to the work which has been done by the actuator. So then only you can claim that the smart structure what you have developed is purely active and not passive. And this can happen only if you have a sensor with you. So you will not be having a single sensor. If you have a smart structure, you'll be having n number of what we call devices. So every devices you need to sense and check whether it is working properly or not. Any variation, any control in the temperature unit, any switch to be on, yeah, off. So where there will be n number of sensors. So it will sense the data and all the data will be collected by the sensory node. Right, so this sensory node then later transmits the data to the controller. It provides the instruction. As per the instruction, the actuator which is there in active media, so will perform the work. So once the work is done, that work has to be adapted for that entire room. So if this goes on smoothly, then we can claim this as a general framework how a smart structure works. So now it's clear.
Yes, ma'am.
Yeah. So anything if the screen is not moved here and there, kindly let me know at the same time. Don't think whether you have a problem or not. Kindly raise your hand.
Okay, ma'am.
Yeah. So related to that, we have studied also the various cantilever beams. I used to tell it is like unimorph, biomorph, everything. Nah? So the same thing has been shown here. So when you say a cantilever beam, it will be usually made up of stainless steel. Okay, so on that you can think about having a single patch of piezo, yeah, double patch of piezo, yeah, more than two layers of piezo, depending upon what is your requirement. But if you have only a single layer, it will be placed on the top of the cantilever beam. If you have bi-layer, it will be one on the top and one on the bottom, right? And you, in this case, you should be having a proper bonding. You should use a proper adhesion layer so that it will be having a good compactness and will yield a proper result. Okay, so this is the thing what you have to keep in mind. And the rest analysis of the cantilever beam we have done in our syllabus already. And here, what they have done is they have checked the experimental part of piezo with that of analytical simulation. Okay, so see here, so when you subject a load, this cantilever can move to and fro. So due to that, there will be like deformation in the piezo patch, right? And as a result, there will be displacement. So if you connect that to an shaker, you can get to know what is the velocity. So with those aspects later, the voltage generated, everything could be calculated, right? This is the experimental part. Similarly, they have simulated here using the software. So they have just shown the deformed shape of the beam after the voltage has been applied as an input. So this analytical result, what they are getting as the displacement, has to be compared with that of the actual displacement what you are getting, right? So both has to be near to it or almost similar. So then you can say that the theoretically calculated data is mapping with that of the experimental one. So here the sensor output voltage of the cantilever beam over time. So this was the actual thing. Red color is the actual thing. Okay, so now down. The tip displacement. So what is the displacement of the tip in actual when you apply a load at the end of the cantilever? So then it moves to and fro. So what is the displacement you are getting at the tip of the cantilever beam? So that data also they have cross-checked. Okay, so this is how you can perform both analytically and experimentally and compare the data. So red is the actual and the blue is the calculated one. So almost both are near to it. So you can compare the results. But to compare the results, the material properties what you're taking should be the same for the analytical approach as well as for the experimental. So you should decide a common thickness of the cantilever beam. Usually it will be of steel. So thickness here it is taken as 0.5. The Young's modulus for it is 210. Okay, so Poisson ratio value, and this is the density of the steel beam what we are using. And similarly, the data for the piezo material also has to be extracted. So without this regular material properties, you cannot feed in. If you feed with a wrong material property, so then the steel what you have used for cantilever in experimentation part will be different, and you will blindly select something in the software, so those material properties will be different. In that case you cannot compare both together, so that thing you have to keep in mind. So they just tested these type of beams with respect to piezo patches. So first one they tested with both top and down piezo patches, and next year the same thing, the test was been done for the given dimension of the cantilever beam with only a single patch of piezo across the top of the cantilever beam, right? So this is the way how you can test. And sometimes you can have a tip mass also at the end of the cantilever beam. I don't think so they have given in the paper. Tip mass means this is the cantilever, right? The schematic diagram. You can have a tip mass here at the end, right? So when you have a tip mass, then the mode of frequency, what you get, the displacement value, right? So everything will get changed. So based on the requirement, you can just think about whether you need a tip mass or you don't need a tip mass. So this is about the things what you have to know, like how the importance of piezo material and shape memory alloys as discussed in the table here will help you to make a smart structure. So how it is related to smart structure, we dealt with the general framework of how a smart structure categorized. So where the actuator will come in the active media and sensors will come in the sensory media. Apart from that, you will check how smart your device is based on the performance, right? This performance is purely depending upon the instructions given by the controller. So controller is nothing but the brain of the smart structure. It should function properly. So once it has functioned and once some task has been assigned and that is done by the actuator, that work has to be adapted successfully in that particular room or home. So then you can claim that the smart structure is performing very well, right? So this they have just checked with a simple cantilever beam structure, both experimentally and analytically. So this is about the paper. So now this is done from my end. So now it's your turn to speak about one by one. With whom shall I start now? Mohan Ambal?
Yes, ma'am.
Yeah. So what is the topic you have thought to speak about? It will be an interaction session related to know how well you have understood all the modules.
Like I should say about the smart device.
Yeah, anything what you have understood, what you want to do further, or what is next. It shows the depth of understanding towards your subject.
Like I understood like what are smart materials and how various factors we can involve in making the smart devices with the use of smart materials like with shape memory alloys, piezoelectric materials, and sensors, various sensors, actuators, help of develop how it performs effectively for mm, and then I also know about how the devices are made.
If any task is assigned to you,
Yeah.
then how will you be able to make that as an smart device or a smart structure? Suppose you have your own room, right? So where do you stay? I won't focus on your entire home, only the room where you stay, right? So if a task is given to make the room where you reside, right, 24 bar 7, so how will you make that specific room as a smart room? Like what is the design concept you have to think about, what are the key features you need to think. So it all again depends upon what is your requirement. So how will you plan, and let me know.
Like what, ma'am? For inside my room,
How to make your room as a smart room.
like temperature sensing, like smart device, we can make it,
Hmm.
and automatic on and off of light,
Hmm.
automatic of door.
Hmm.
If any changes in the surrounding me, there should be like to me to detect if there's some surrounding.
Okay.
With all this, we develop a sensing and uh, help use, then we make up a smart device.
How do you control? How you provide the instructions? So without that, how it can be claimed to work properly?
Like with the help of actuators, we control sensors, it senses, and then actuators, it performs the actions according.
Which will control what you need for a controlling unit. Every day I just tell the same thing. Today also in case study I've told what you do for controlling media then.
Controlling.
What is needed? If you just have a sensor and actuator, will you can claim that as an smart structure?
No, ma'am, we need some controlling.
That's what I'm telling. What will be your controlling unit? You should at least have a remote monitor, your computer embedded with the software, with the electrical signal, circuitry systems, and this has to be connected from the actuator to the controller, sorry, from the sensor to the controller, from the controller to the actuator, right? And you should be having an chip which will be checking the adaptiveness of the room. So if everything works proper in a given circuitry design, then you can say that it is working. So before making it to actual, you should stimulate in the software and check. So many things are there. You cannot blindly say it as a smart structure only by having sensors and actuators. Okay.
Yes, ma'am.
So only I asked. And now I'm asking, I think few have got disconnected. If I need to give the attendance, all the people who were there until now has to log in back to the class immediately. Okay, just call them, yeah, post them a message. I need all those back. Currently, I'll be speaking with Srinidhi.
Okay, ma'am.
Yeah, do that work. Srinidhi, hi. How are
Hi,
you?
ma'am.
Yeah.
Good morning, ma'am.
So, how you feel about the subject? All done. All case studies are done, right? And on Monday you will be presenting the seminar. So before that, I just wanted to take an brief interaction with you guys. So, what did you understand basically from this subject?
How smart material is for the technology, how it is helping, ma'am.
Hmm.
Like technology has become higher.
Hmm.
There is necessity of smart things in the world. So
Hmm.
this subject coping up with that.
Okay. So
So
if
you
I
asked
just,
her
yeah,
about
tell.
you asked about the smart device. You are asking like, for example, in the hotels and all, if we go to ask for something which is high in technology,
Hmm.
like voice control and temperature control things.
Hmm.
So this is essential, ma'am.
Okay. Suppose if I ask you to select any one of the class of smart material, which you will be selecting?
Smart metal class, ma'am. Sensors, ma'am.
My dear, sensor is a device that is not a smart material.
Yes, yeah.
You have huge classification of smart materials, right? In
Yes,
that,
ma'am.
if I ask you to select one material, which you will be selecting?
Material.
Yeah, smart material, which you will be selecting.
Mm,
We have dealt with piezo, we have dealt with shape memory alloys,
yes, ma'am. Like
ER
we
fluid, MR fluid,
are, I can go with MR, ma'am.
MR fluid. Okay, so if you select MR fluid, for what application, for what device you think about?
Because it is more conventional than any other materials we have asked, ma'am.
Hmm. So, if you are provided with MR fluid, which device you think about making through it?
Device. Something related to automobile, ma'am.
Okay. Can you just name few applications of MR fluid?
Yes, ma'am. Um, I have written.
Think. I'll just speak to Mohanambal. Did you put a message, Mohanambal?
Yes, ma'am. I posted a message.
Yeah. And where is Mr. Danush?
He didn't join from the morning class also, ma'am.
Okay. And others who were there, just post a message. I can give the attendance only they are back.
Okay, ma'am.
Call them or else. Yeah, Sridhi, tell me the applications.
Uh, Applications like in automobile, I told ma'am.
Mm-hmm.
Uh, is done for that cam system.
Okay.
For that we can do, ma'am. That device is good for MR.
Okay. So, fine. So, the topic which has been given to you all, prepare well and present on Monday. Okay. So, now I'll be going to Mr. Sandesh.
Yes, ma'am.
Yeah, how are you, Sandesh? Okay, why your friends are not there today? What's the problem?
It's internship.
Internship. Okay. You guys are going in the morning or afternoon?
No, and they have given us a project, mini project.
Okay. Yeah, Sandesh, tell me now. Like, what do you understand from the syllabus? How you
And
feel about the smart structures?
how we can uh, mini, decrease the size of actuator sensors which can be
Mm.
embedded beams or mechanical parts to steady those vibrations and all.
Okay. So suppose if you are well versed with all these smart materials and smart structures, if one of the person from any industry or organization has some need or requirement to make a smart device, so and he comes and tells you that this is my requirement, so in which I want to make it as a smart device. Suppose he has a specific laboratory. Okay, so you just want to make that laboratory as a smart laboratory. And it tells that this is very much essential because always we cannot keep the lab assistant there and wait from morning to evening, as many experimentations will be done 24 bar 7, which has a long period of time wherein no human being can wait for so much time, because for some precipitation, some ball milling parameters has to be run for 24 hours, wherein at night time you have to put another person in shift. So all these are complicated. So if he requests you to make a smart device, sorry, smart laboratory to control all these aspects and see that it is working freely, systematically 24 bar 7. So what will be your ideas and thoughts?
Um, laboratory maintain the temperature and humidity of the lab. Um,
Louder.
Maintaining the temperature and humidity of the lab.
Only by maintaining the temperature, the other things can be controlled.
No,
Then suppose you have like 7, 8 experiments which are going on parallelly. Some need to be offed by 3 hours, some need to be offed by 5 hours, and some in between you need to add some ingredients if it is necessary for that process. And if any stirring a soldier thing is been needed, so that has to be changed, the sample from one end to the other, without the intervention of human being, just as a smart laboratory, how they can work.
and by the help of controllers, sensors, and actuators, which is controlled by a microprocessor.
But how will you frame all these together into a single microcontroller? I've told so much applications with respect to domestic, with respect to industrial, and many case studies with respect to individual applications. Now, at least open up your mind and let me know. I told you how many devices you have within the room. That much has to be sensed means that specific number of sensors has to be there with you. And all those things has to be connected through sensory node. Then only the data sense could be recorded. How many times did I tell you? Today also I've told, na? Then why you people are not telling? At least now speak out fully. Yeah, Srinidhi, carry on. After that, what we need to do?
Yes, ma'am.
If it, where were you? Until now, I am discussing. You're telling me yes. Yeah, continue with the answer. How you can claim that as a smart laboratory?
By voice control, we are told, ma'am. One temperature control.
What control?
Temperature, ma'am.
Only with temperature, how it will work? What about the others?
Others like voice control, ma'am.
How voice control will work? Suppose there are like 4 to 5 experiments which are going on. Some needs to be offed by 3 hours, some needs to be offed by 5 hours, some needs to be added with some ingredients in between during the process, and some needs to be controlled with temperatures, and some has to be kept in vacuum chamber, and some has to be transferred from one media to other media and check some pH values also. How all these could be controlled?
Before it is well programmed by a system, ma'am. Like at what time, what should happen?
You should have a brief input data how it will happen. So that will be the scheduled task what will be there in your PC already. But you should be having n number of sensors based on n number of device what you have to keep in track. So from every experiment unit, you should be gathering the data. It should be sensed. And all those sensed data has to be given to an sensory node. So it will be having the grab data from each and every experiment which is ongoing. So that grab data will be fed to the controller, which is nothing but your remote monitor or a computer. So in your computer, you will be having the entire schedule of all the experiments which is designed, which is the time in which you need to stop, you need to on, in which you need to add any active members into it or any ingredients. Yeah, transferring of the liquid media from one end to the other. So based on that, with respect to the sense data, the controller what you're using have to do the work of your brain. How when you see something your brain will give the sudden decision, right? In the same way the controller has to provide the instructions. Okay, so this is the sense data, provide the instructions at right time to the actuator so that actuator will perform the work. Got it?
Yes, ma'am.
So when it is done, so that room should be having a condition to take the adaptiveness with respect to the changes which has been done. So if any in need of robo arm is needed also, that could be also considered. So this is what I expected the answer from you people. That shows you need to read regularly, keep yourself updated, see the things related to these materials, what are the new technologies which are coming on. Then only you can excel well in this subject. Okay. You should be knowing real time applications or at least should be able to accept the task and do it accordingly.
Yes, ma'am.
Understood now? So now I give you a small example. The mobile, we call this as a smartphone, right? Why it is called as a smartphone? Can anyone answer me?
Ma'am,
It could be called as a regular phone. Why it is called as a smartphone then?
Because of when such whatever necessary things can be done within home.
Louder?
And that we can accomplish the work, ma'am.
It can sense, first of all, right? Without pressing the password, only with the help of your thumb impression, it can help you to open the screen, right? So after that, there are many things what you can do it in a smart way, which was not there before. In the regular phone, we used to have the keypads, right? So can you see the keypads in today's phone? No one will use that. So you have so much of technologies which are making each and every step using of mobile to be very smart. You can access, you can transfer the amount from one end to the other, transactions, book your bus, flight, train, all possible things you have in a single. No need to carry even laptop if you have a smartphone. Will you agree or not?
Yes, ma'am.
Your all work will be done. You can pay your electric bills, phone bills, you can recharge, right? You can transfer money to your friends from one end to other. You can do your shopping, everything. All the requirements satisfied in a small single piece. Why it is giving you the all the requirements which has been needed, and it is providing you the comfortness in a single stretch because it is acting very smartly, right? So it is satisfying all your needs. You don't want to go for a retailer shop to buy anything you want to buy, even your domestic applications also you can do it using their mobile. Right, no?
Yes, ma'am.
Yeah, similarly, you have to apply this concept of smartness. That's what I told. If you want to make a room smart, how will you do? Your friend told only sensors and actuators. Without controller, she forgot. So all these things is needed. A microchip, a motherboard, where you have a controlling unit which provides the instructions. It could be a micro level device or it could be an actual size device. But still, you can see that how smartness could be developed. Okay.
Yes, ma'am.
So you should feel yourself get updated. It's not like just listen to the class, go home, and just forget which has been told. You should provide work to your mind. Think still more better what could be done. So much good amount of subjects you have in your curriculum. Try to implement in one or the other way. That shows that you are in MTech. You are not in UG. You are in PG. You should think in that way. Okay.
Okay, ma'am.
Yes. So next session it should not be in this way. Keep yourself updated. Everyone, please write your name and USN in your chat room. Kindly type your name and USN in the chat room. Danush, absent. Mithun, Mohan Ambal, Sandesh,
Yes, ma'am.
Srinidhi,
Yes, ma'am.
Yes, ma'am.
Sukrut. Sukrut is not there. And Sri Harsha, he was there. I don't know where he has gone. Fine, then take care. Have a good day. Prepare yourself well for the presentation. I need a total perfectness in your presentation and a thorough knowledge. It is not like only for namesake you're doing. Please study well, gain knowledge, and then come and present to me. Okay?
Yes,
Okay.
ma'am.
Yeah,
Thank
okay
you.
then. See you. Bye bye.
Thank you, ma'am.
Yeah, yeah, bye.